Imagine a garden that, on paper, just shouldn't work. It's like a complete paradox.
Okay, I'm intrigued. Set the scene for me. What are we talking about?
Okay, so picture a space, right?
Mm-hmm.
It gets absolutely zero direct sunlight, deep shade.
Mm-hmm. So you're thinking cool, damp, maybe a bit mossy.
Exactly what I thought. But wait, and this is the kicker. This space is also really high up. High elevation.
Oh, wind.
Constant, strong, drying winds.
Wow, that's a nasty combination. Because usually shade protects a plant from drying out, no sun to bake it.
Right.
But with high wind, you get massive evaporation. So you have a low energy spot from the shade, but it's a high thirst spot because of the wind. That's a very, very hostile microclimate.
It is. It's an ecological contradiction, and it's exactly where we're going today. We're doing a deep dive into this amazing piece of documentation from qianmeng.org.
Okay.
It's a post titled Notes on Gardening, Part 780. Lessons in Windy and Deep Shade Microclimate.
And the date on this is January 18th, 2026. So this is, fresh thinking.
Yeah. But hold on, did you catch that part number?
Huh.
Part 780.
I know. It's incredible, isn't it? That number just stopped me in my tracks. 780 posts just on gardening.
Wow.
And that, I think, is the key to this whole thing. The author, Ang, he calls himself an old software plumber.
Software plumber. I love that. It's so humble, but so perfectly descriptive.
It's great. And it's not just a cute title. I mean, if you look around his site, there's notes on Python, notes on Elixir, notes on fish keeping.
Oh, wow.
This is a systems thinker. He documents everything. He's not just a guy with a watering can.
The whole worldview, right? A plumber looks at a system, whether it's code or a balcony, and sees inputs, outputs, flows, potential bugs.
Precisely. And that's our mission for this deep dive. We're not just here to talk about pretty flowers. We're going to break down how a systematic troubleshooter debugs a biological problem.
Okay.
We're looking at this specific balcony experiment to understand how you match a living thing to a buggy environment.
So let's load up the environment variables to stick with the metaphor. What's the specific hardware here?
We are on Ang's front balcony, and he says he spent many moons just assessing it. He's observing, not rushing.
Why?
And he's found two major constraints. First, light. It's a deep shade microclimate.
Which, for anyone listening who gardens, usually means you're limited to, leafy stuff. Things that grow slow, no big flowers.
Right, no direct sun hits the balcony. But, and this is an important detail, he knows it gets 12 hours of bright indirect light. So it's not a cave.
Okay, it's illuminated, just not baked.
Exactly. So that's variable 1, low solar energy. Variable 2 is the elevation.
The wind.
The wind, it's high up, so it just catches the wind. He says it's quite windy.
And this brings us right back to that paradox you mentioned. I see a shady spot, I think, oh, perfect for ferns, things that like it damp and still.
Mm-hmm.
But the wind just destroys that whole idea.
You completely flips the script. Wind speeds up transpiration.
Transpiration.
Yeah.
Break that down for us. It's basically the plant sweating.
Right. Pretty much. Water evaporates from the leaves through these little pores. Wind acts like a vacuum cleaner, just pulling that moisture right out of the plant and off the soil.
So a place that should be low maintenance and wet
becomes a dry environment that needs constant watering. He says that explicitly. The wind creates a dry environment despite the shade.
So it's a trap. You treat it like a normal shade garden, your plants die of thirst. You treat it like a sun garden, they starve for light.
It's a hardware conflict. The system requirements are contradictory. You need a plant that's part desert dweller, part forest floor dweller.
So what does a software plumber do? He runs tests. He runs unit tests.
He does. He basically takes his plant collection and deploys a few different apps to see what will compile. He tried basil, coleus, and Indian borage.
And I want to look at the crash logs first, the failures. That's where you learn the most, right? So basil and coleus, super common plants. Why did they crash?
2 fatal errors. The first was just the water demand. Because of that wind, they needed constant watering. The plumber had to keep intervening to keep the system running.
That's bad code. You want a program that runs itself, not one you have to reboot every hour.
Exactly. It wasn't a sustainable system. But the second problem was structural. He says they became leggy.
Leggy. You hear that term all the time. But what's actually happening to the plant? Why does it get all long and weird?
It's this Fascinating, but also kind of desperate process called etiolation. Basically, the plant panics when it's not getting enough light.
It panics.
Yeah, it floods its system with hormones that cause the stem cells to elongate really, really fast. It's trying to sprint towards the sun.
It's stretching to see over the crowd.
Perfect analogy. But because it's growing so fast, it's weak. It's not building a sturdy trunk. It's building a flimsy, desperate ladder.
And then you add the wind.
And then you put that tall, weak, flimsy plant in a wind tunnel. It's a recipe for disaster. They were stretching for light that wasn't there and couldn't handle the physical stress.
Okay, so basil and coleus are out. Too needy, too weak. But the next failure is the one that really got me. Indian borage.
Yeah, that's an interesting one.
I know that plant. It's basically indestructible. It's a succulent. It holds its own water. If anything could survive, I would have bet on the succulent.
You'd think so, right? Succulents are built for drought. They have those thick, fleshy leaves to store water, so the wind shouldn't have been a big deal for it.
But it failed. Why?
It failed because of the other variable, the light.
Ah.
Succulents evolved in high sun environments, deserts. They need that intense energy to keep their structure compact and thick. In deep shade, even a tough guy like Indian borage just can't. He noted it struggled, resulting in weak, elongated growth.
So it got leggy, too. The same problem as the basil.
It did. And that's such a key takeaway. You can't just pick a tough tool. You need a tool that's tough in the specific way the environment demands. The borage was tough against drought, but weak against shade.
It's like wearing a bulletproof vest to go swimming.
That is a vivid way to put it. But yes, the protection was for the wrong threat.
Okay, so the unit tests are failing. The basil is thirsty. The coleus is weak. The indestructible borage is a noodle. But then there's a winner.
Enter the fern.
The humble fern. And Eng calls it the clear winner. What was so different about it?
Well, look at his metrics. First, minimal intervention. The basil needed him constantly. The ferns just thrived. They were efficient. They're understory plants. They evolved for shade, so the light was fine.
But this is my favorite part. The really cool part. He didn't go out and buy these ferns.
No, this is the best bit. He writes, and I'm quoting here, "Interestingly, these ferns originally propagated themselves here via the wind."
That's almost poetic. The very thing that was killing everything else, the wind, literally delivered the solution.
It's perfect. It's natural selection in action right on his balcony. The wind carries spores everywhere. The ones that couldn't handle that spot died. The ones that grew were already pre-selected by the environment to survive there.
The balcony debugged itself.
It did. The delivery mechanism filtered for the right genetics. Eng realized he didn't need to force a solution. He just needed to look at what was already trying to grow.
That's such a huge mental shift. I think most of us garden by, imposition. We seed a plant we like, we buy it, we stick it in a pot, and demand that it grow there.
And then we wonder why it dies. We haven't read the error log for our own back porch. Eng's approach is observation over imposition. He's listening to the data.
So he identifies the fern as the right software, and he decides to double down.
He does. He says they'll be the centerpiece. He's standardizing on the platform that works. And he's going a step further.
The vertical garden.
Yep. He plans to move them from pots to a vertical arrangement on the wall to save space and, as he puts it, lean into their natural habits.
Which makes total sense. Many ferns grow on tree trunks or rock faces in the wild.
Exactly. They're epiphytes. They're used to clinging to vertical surfaces and breezy spots. A wall is actually a much better home for them than a pot on the floor.
But even with the right plant, he realized the infrastructure was still wrong. The soil itself was bugged.
Right, this is the recoding phase. This is where the plumber really gets to work. He realized his standard high drainage potting mix was a total failure there.
Wait, hold on. High drainage is like rule number 1 of container gardening, isn't it? You want water to run through so the roots don't rot.
Context is everything. High drainage is the fix for stagnation. What's the other big variable on this balcony?
Oh, wind. The constant drying.
Right. It's a hairdryer. So with a high drainage mix, the water would rush through and then the wind would evaporate what was left before the plant could even drink it. The soil was drying out way too fast.
So the standard operating procedure was wrong for this specific environment. He has to patch it. What's the fix?
He's pivoting to a mix with a high ratio of cocopeat.
Coconut fiber.
Yep. It's the byproduct from coconut husks. And its superpower is that it holds onto water. It's a sponge. Now, in a normal, damp, shady spot, that could be a death sentence. It could cause root rot. But here, in this high evaporation zone, it perfectly balances out the drying effect of the wind.
It's a countermeasure.
It's a buffer. And he notes that ferns are remarkably adaptable, so they should be fine with the wetter soil. He's matching the substrate to the atmosphere.
It's just system calibration. You have a drying variable, the wind, so you add a wetting variable, the cocopeat, to find equilibrium.
That's it, exactly. Homeostasis through engineering.
So let's look at the whole system now.
Yeah.
He's got the right plant, the fern. He's got the right deployment strategy, the vertical wall. And he's got the right infrastructure, the cocopeat soil. So what's next?
Well, this is where the plumber part really shines. He writes, "The next step is to clear the area so I can proceed with my grouting work on the balcony tiles."
Of course.
It's so practical. The biological problem is solved, so now it's back to structural maintenance. The tiles need fixing.
I just love how mundane that is. It reminds you this isn't some sterile lab. It's just a guy's balcony that needs a bit of home improvement.
It also shows how methodical he is. He can't do the fun part, installing the vertical garden, until the messy prep work is done. There's an order of operations.
You can't deploy the front end until the back end is stable.
You're really committed to this metaphor.
I have to be. The man wrote 780 posts on gardening, alongside notes on, advanced programming languages. You have to respect the vibe.
It's appropriate, and it brings us to the bigger picture, right? Why should you, listening at home, care about this specific balcony?
Yeah, what's the takeaway if you don't have a windy, shady apartment?
It's that we all have microclimates. That spot next to your desk where the AC blasts all afternoon is a microclimate. The corner of the yard behind the shed where the rain never hits is a microclimate.
So the lesson isn't go buy ferns.
No, the lesson is stop trying to force the basil to grow in the wind tunnel. Aang saw it fail. He understood why it failed, and he moved on. He found what the environment was already selecting for, the ferns, and he optimized for that.
It's really humble when you think about it. He let the wind tell him what to grow.
It is. It's admitting the environment is stronger than your personal preference. You can't argue with the wind. You can only add cocopeat to your soil to deal with it.
And that soil point is huge. I think we all just grab the bag that says potting mix and assume it's one size fits all.
Which is a huge mistake. The soil is the interface. Aang was manipulating that interface. If you're struggling with the plant, don't just blame the plant or your black thumb. Look at the soil. That's the variable you have the most control over.
It's the code you can actually rewrite. You can't rewrite the sun.
Precisely.
I want to go back to that leggy idea for a second because it feels like a bit of a philosophical warning. The basil was stretching itself thin, trying to find something that just wasn't there.
It's a stress response.
Mm.
And it creates a weak structure that can't support itself. The ferns, on the other hand, they were compact, they were efficient, they weren't fighting for resources, they were using what was readily available.
So if you feel like you're constantly stretching, getting weaker,
Maybe you're in the wrong microclimate. Maybe you're a succulent trying to live in the shade, and you need to find a spot where your natural strengths are actually an asset.
that's a powerful idea. If you're always fighting your environment, you become leggy. If you find the right environment, you thrive with minimal intervention.
Minimal intervention, that's the goal. A system that runs itself. A garden that doesn't need you to panic water it every morning is a successful system.
So, to recap our deep dive, we started with this really hostile environment. We saw a software plumber run his stress tests. The usual suspects crashed. Even the tough guy succulent failed.
And the underdog, the fern, won because it was literally born in the storm that was killing everything else.
And we learned how to recode the soil with cocopeat to patch the system's moisture leak. It's a masterclass in adaptation.
And in designing around constraints, not just fighting them.
So here's my final thought for you, the listener. It's a little challenge inspired by those fern spores. The next time you walk past a crack in the pavement, or you look at that patch of weeds in a forgotten corner of your yard, don't just see a mess.
Look closer.
Ask yourself, why that plant right there? Nobody planted it. Nobody waters it. It cracked the code for that specific hostile microclimate when nothing else could.
Those aren't just weeds. They're the winners of a million-year-long stress test.
Maybe we should be taking notes from them.
I think Aang would agree.
That's it for this deep dive into the software plumber's garden. Thanks for listening.
Keep observing.